Assalamu alaikum wa rahmatullah. In the previous lecture, we have started talking about desertification indicators, and we have taken an example of the indicators. In today, we will continue with the other two examples. So we've started with rangeland health indicator, and today we would continue with DPSIR framework and soil quality indicator. And at the end of the lecture, we would see the differences between them. Without further ado, let's begin. Before we go deep into the details of the lecture, I would like to emphasize on a very important concept, the difference between framework and indicator. What we are seeing in these examples as rangeland health, DPSIR, or soil quality indicators, these are all called framework. And basically, a framework is a tool that is utilized to focus on a problem, to understand a problem, to be able to analyze a problem and focus also in the solution to that particular problem. Framework uses indicators to do so, whereas the indicators are parameters that are actually used to see the trend or the change of a situation over time when it comes to land degradation due to human and climatic activities. Now, let's begin with DPSIR framework. DPSIR stands for drivers, pressure, state, impact, and response. And if we look at this framework, the history of this framework, it was developed by the European Environment Agency for its soil strategy, because they wanted to get a soil conservation, or they want to approach a soil conservation of the soil. At that particular time, it was only used for soil quality. But nowadays, this framework becomes a worldwide use in many aspects. It can be used for different environmental issues, even analyzing like eutrophication or things related to soil or climate change. It can be used for water issue and the biodiversity. Now, if we look at what makes this framework famous, it would actually focus on that this framework actually link between the causes and the which are considered as pressures and drivers, and the solutions, which are basically the response. And if we look at it, it consists of drivers, pressure, states, impact, and response. So this type of framework can link between all of them, and even can link between the interaction between any one of these. And I will give you an example of how to utilize this framework. But this framework basically uses 54 indicators. So if we compare it with the rangeland health, this framework uses more indicators, because the rangeland health only uses 17 indicators. Now, when it comes to understanding what are the drivers, so what do we mean by drivers, pressure, states, impact, and response, we can say that drivers are basically our human needs. Like, we need agricultural protection, we need transportation, we need energy, and we need many other different things. The pressure are basically our activities and the impact of our activities. For example, let's say like the urbanization, the construction, deforestation, the forest fire, and you would see that the pressures, it's not necessary to be something negative, but it can be something positive. If we look at the state is basically describing the condition as a result of our activities, as a result of the pressure, whether it's actually in terms of the soil quality, air quality, or let's say the water quality, what exactly. The impact is the result of the change in the state. Let's say that our activities were negative, so they impose a negative impact on the state. So it causes, for example, loss of biodiversity, it causes climate change, water stress, and whatever kind of things. The response is the action. It's basically describing our management scenario. It describes our activities in response to the impact. So what are we exactly doing to make the situation better, or to maybe our activities or our management scenario might have also a negative impact. Now, what I wanted to say here, that this kind of framework link between the causes and the solution, because you can exactly see directly the impact of your response on the pressure, or on the drivers, or on the state, or on the impact, and so on. So it's a kind of dynamic, or let's say a chain of interactions. Something also that I wanted to emphasize, that the drivers and the pressure describes actually the social impact, whereas the other things here, the impact and state, describes the environmental things. So we can see this type of framework uses or integrate the sustainability pillars, integrate the social, economic, the environment, and the political things, because the political can be integrated in the response action. Now let me give you an example so this framework becomes clearer for you. Now let's look at the drivers. The drivers, as we said, it's basically our need. So for example, a need of industrialization to provide the goods for us, the transportation, and the agriculture. Now what is the pressure? The pressure is basically describing our activities and the impact of these activities. So it can be, for example, our activities, emission of pollutant to the environment. Now, what happens to the state? When we look at the state, we can see that the state basically describes the soil, water, and quality. So the state, due to these activities, can be affected, and it can has an impact on the state. So the pollution here, the emission of pollution, affects the state, causing the biodiversity losses or economic damage. And what is the response? Our response can focus on one of these aspects. It can, for example, focus on the for example, the pressure, whereas like producing a clean product, or improving the public transportation to be like clean energy, or for example, implementation of taxes, imposing taxes, or whatever things. And then you can see exactly what happens to the drivers or the pressure, or so these things are actually in a continuous cycle. Now let's look deep at this type of framework. As we said, this type of framework uses 54 different indicators. An example of these indicators are listed here in the table here. So we have, for example, an indicator that focuses on the climate, and it measures different parameters. It measures, for example, the air temperature, and there is a clear thing of the air temperature, rainfall, aridity index, and there are equations that we use to get the aridity index, the potential evapotranspiration, rainfall seasonality, and rainfall erosivity. Then it looks at the air, at the quality of water. So it looks at the quality, the quantity, the groundwater. What I wanted to say here, what I want you to focus and to see here, that each one of these indicators have different parameters, and in these parameters we quantitatively assess this parameter, and of some of them we assess them qualitatively, like what you will see. So his soil, vegetation, runoff, fire, agriculture, as you see here for the social impact. So for the social impact, some of them are qualitative measures, but this is actually the idea. As you can see from the indicators, it basically covers all the aspects of the sustainability pillars. So it's a kind of comprehensive approach. At the end of the day, they should be a presentation of the results. They should be a presentation of the output. So what is exactly the output? If we remember the framework of rangeland health, the output was a map that contain the rating. What is the output here? The output here can be either tables, or can be a framework like this, summarization of, like, listing all of the things here, listing the drivers, the pressures, the state, and the impact, and then you can think of a response to this scenario. Something also I wanted to emphasize that this type of framework uses data. These data can be primary data, a data that can be directly collected from the field, either through, for example, sensors or measurement, like looking at the soil and the water quality, the vegetation and the climate, or, for example, interview with people or questionnaires. Or it can have also some data which are secondary, called secondary, which means they are actually published data, published by government organization or NGO, non-governmental organization. And in this type of data, which are published, can be got from the website, from the websites of these governmental organizations. Now, if we look at the output, which can be a table or it can be something like this. This is the output, right? It lists the drivers, the pressure, the state, and the impact, and you can see the interaction. So for this particular example, soil quality indicators, another type of indicators. What is the difference between this and the other two? We would see. Basically, this type of indicators was, if we come to it, it's basically called soil quality. And soil quality is defined by Doran and Parkin as the capacity of soil to function within an ecosystem in order to maintain the productivity and the environmental quality, and therefore promote a good environment for the plant and the animal health. If we look at the soil quality indicator, it focuses basically on three different aspects. It integrates three different aspects which can be seen here. It has some physical indicators, chemical indicators, and biological indicators. This framework actually utilizes 39 different indicators listed here. Now, you can see that from this diagram that the physical or the chemical or biological indicators, they are actually have an interaction between each other, which means that anything that affect the physical or any physical parameters that can be impacted can actually have a direct effect on the biological or the chemical indicators. And I'll give you an example. If we look at the physical indicator, you can see you have soil structure, aggregation, infiltration rate, and so on. Now, if you have an effect on the soil structure, it can also have, let's say, like compaction, for example. It can have a direct impact on the biological indicators, like, for example, the root growth, for example, the soil animal that exists in the soil, and it can affect their biodiversity. Chemically, what happens? Well, when you have a compaction, it can affect the water flow, and we know that water is basically what carry out or dissolve the chemicals in the soil. Like it can has a direct impact on the pH or the nutrient or the salts in the soil. So we can see that these parameters or indicators actually has an integration, or let's say they are actually interacting with each other. Now, I'll give you an example here and more emphasis that, for example, the soil quality cannot be measured directly. We cannot measure the quality. We cannot measure the capacity of the soil to function and so on and so on. But we can measure some of the parameters which are actually sensitive to change. And these parameters are basically properties of the soil. For example, physical indicators like the bulk density, the pore sizes, and the availability of the water, the penetration resistance, and so on and so on. Or the biological indicators like root health, organic matter, active carbon test, or the chemicals like pH, phosphorus, magnesium, and potassium, and so on. So basically, you go to the field and you measure all of these things. Each one of this indicator or parameter has a direct effect or has an effect on process that exists in the soil. Some of them might affect a lot of processes, while others might only have a small impact on specific soil processes. If we look, for example, at the aggregate stability, which is a physical indicator, this one can affect the aeration, the infiltration, the roots, and the and actually the roots and the crusting. Whereas if we look at the soil texture, it can affect almost all the soil processes, all of the soil processes. Another example, if we look at a biological indicator, like for example, like the root rotting, this can affect actually the process of developing soil-borne pest pressures. If we look at the chemicals like the pH, when the pH of the soil is changed, it can create toxicity in the soil because the pH is also can affect the nutrient availability. We know that some of the nutrients are available at high pH, become very soluble and mobilized, while others can be available at low pH. So this can create toxicity or can affect the nutrient availability, and so on. Now, what is the output of presentation of this kind of parameter? Well, here it shows you a table and it shows you a graph. This is basically some of the types of the data that you collect. So for example, you collect data like some of the elements, and this is basically related to the chemical indicators, or you can later on link between the parameters that you collect and convert them to a score, because you need a score for this type of indicator, and you would see how to use the score. So you have cards, we call them like score cards, and these score cards actually basically nothing, they're just like curves with colors. This type of indicator or framework uses colors and scores. So if you know the value of your, for example, active carbon, and your active carbon is, for example, 700 ppm, and you know your soil texture, you measured the soil texture, and you know your soil texture that is clay. So you choose the curve, or you look at the clay curve, you try to draw a line here, and then it tells you the score. In this case, for example, the score is 5.5 and the color is yellow. Now, what does it mean to have a score 5.5 and the color is yellow? Let's look at this. The final output of this framework is basically a nice table like this. And in this table, you see that you have the indicators, you have the physical, you have the biological, and you have the chemical aspects. And you have different parameters that you measure. Then you have the value that you assess, and then you have something called rating. Now, what is rating? The rating is basically the score value and the color. You notice that you have different colors. You have red, yellow, and green, and you have value. So the value, if you look at it, the rating as a number, as a value, is basically from 1 to 10. 1 or closer to 1 means you are in very bad situation. Closer to 10, you are in a good situation. Now, you convert also this number or this score into a color, which can be red, yellow, or green. Now, for the color, there is a range. For example, for red, if the condition is very bad and the value is less than 3, the value of the score is less than 3. For a yellow color, if the value is actually equal to 8. While if the value is is actually larger if the value is greater than 8, then you have actually a green. So again, if the value is 3 to 8, then it's yellow. If the value is greater than 8, it's green. And again, green color means safe side. Red color means very bad condition. That's why it's red. It's an alarming situation. You have to do something about it. You would also see here in this table, it listed the constraint. The constraints are basically what actually exactly happening here. For example, in this condition, you have a soil stability. The rating is 1, which means it's very bad condition. And the constraint, the things that you need to focus on solving, is basically the aeration, infiltration, and rooting. Later on, you have also something called percentile rating. The percentile rating is very simple. You multiply the rating times 10, and then it tells you. So it's the percentile is ranging from, let's say, from 0 to 100. And you can see, or from 1 to 100, and you can see here how it looks like. actually from 0 to 100. If you look at the end, you have here an overall score, and you have an overall condition rating. So now let's look at it. Why this one is like this? Basically, you can see that this one now becomes simpler. Why? Because it has all the details. It has colors and score, so it's actually visual. So if you give it to farmers, they can even understand it because they know that red means all bad situation and so on. Now let's look at this example. In this condition, this actually was done for a farm which has been intensively cultivated for vegetables. And because of this, you can look at the condition here. You can see that the physical condition of this farm is very, very bad. The aggregate stability and the water capacity is basically very, very bad condition, and you have to focus on them. If you look at the chemical properties or the chemical condition of the farm, you see that you have no issue. So you don't have to focus on the chemical condition, but you have to pay attention mostly to the physical parameters, particularly the aggregate stability and the available water capacity. And you also should pay attention to the other parameters here in yellow, because otherwise, if you don't do anything, they becomes in a worse situation. Now, if you compare between all of these three indicators, the rangeland health, the DPSIR, and the soil quality, you can see that if you look at them in terms of indicators, you would see that DPSIR uses more indicators than the others. If you look at the type of data that they utilize, the rangeland health utilize actually primary data, which are basically quantitative and qualitative. It means that you measure these data, you measure them. Whereas DPSIR basically uses two types of data. It uses actually primary and secondary data. It uses data that you measure quantitatively and qualitatively, and also secondary data that you get from websites, for example. So it's more comprehensive. If you look at the soil quality, then it only uses the primary data. Now, if you look at their comprehensiveness, and what I mean by comprehensiveness, focus on the sustainability pillars, the socioeconomic, environmental, and political and institutional aspects. If you look at the rangeland health, it only focuses on the environment, particularly the soil and vegetation. Whereas if you look at the soil quality, it focuses only on the soil, so it's only the environment. If you look at DPSIR, it focuses basically on all the aspects here. So in terms of the comprehensiveness, it's better. In terms of linking the cause and the impact and the response, you would see that the DPSIR is the best because it links all of them. The others focus only on the impact. And in terms of easiness of use, you would see that the easiest part is basically the soil quality. I mean, easy, in my opinion, for the farmers. For the people who might not know so much science, soil quality framework is easier for them because it gives them color and rating, so it's easy. If you look at the rangeland health, it's also easy, but the soil quality is easier because of its design. The DPSIR is more complicated, and here it needs like somebody who can explain and interpret the data. That's all about this lecture. What I'm expecting from you, basically, not to memorize all the details, but at least to know the differences between them. At least you should understand this table very well, and you should know the difference between them and which one is better to use and why, and so on and so on. But I'm not expecting from you to memorize the parameters, the type of parameters that it uses, and so on, because you don't have to memorize them, but you need actually to utilize them. And I will give you an assignment that is actually utilizing the indicators, or one of the indicators, to evaluate the desertification. So thank you so much. I'll meet you in the discussion session, and I hope that you enjoyed this lecture. Prepare your question. Also watch the other videos that are posted for you, and see you to that time. Take care and goodbye.